I swear, it was like 15 hydrocodone a day.
What the?
So I worked in oncology, like she had like some kind of
Oh.
blood disease, and like he finally was like, I'm not writing this anymore, you need to go see pain management, and she was so freaking mad.
Right, and that's why people with that.
Yeah.
So you get a C-section, and they send you home with Tylenol.
Okay.
Considering that, you've been cut up,
Yeah.
you probably they push down on all your organs with the elbows, stuff, everything inside is sort of, that's painful. But because now it's so much paperwork to prescribe.
No,
And I feel like everything has to be done triple again.
and they give it to you in the hospital, but they don't usually write it to you after. Yeah.
So yeah, you'll get one with Tylenol, which is not
Or ibuprofen.
for something.
Well, even give
like
it to
that.
you, even if you don't have a C-section, because I mean,
Mm.
it hurts still after. It's
Yes.
not the best feeling in the world, but they still give you Tylenol 3. But I refused it because I was breastfeeding. I was like, they're like, it doesn't pass the month. I was like, I'm not gonna take the chances. Let's just ibuprofen.
It sucks.
Yeah.
And then they're focusing so much on the addiction side. That they're not looking for alternatives for people who do that way, who do. So, well, what happened? Some people are going to different routes and now they're going, and then getting fentanyl and some
Well,
things.
with this one, they have Suboxone clinics, which it's to help you wean you off like opiate addiction or like methadone addiction. But Suboxone is literally almost the same thing as methadone.
And they're from the same kind, chemically.
Yeah,
they're from the same.
and then, but people will go and like, it's not really, it's supposed to help you because they like lower your dose, over time. But at the same time, like people are, if they go back and they're just like, oh, well, I'm having terrible withdrawals, and they'll just up it again. So it's not really helping. My sister was addicted. This is how I know. Huh? Methadone's used to get you off like painkillers too, but people get addicted to it too and then they abuse it. And so it stimulates kind of like the same way as I don't know, it's crazy. In some countries they have places where you go shoot up or use drugs with commercial like no. Well yeah, kind of, yeah, but you can like shoot up and work in overdose and use their use.
Okay. This is chapter. Okay, so exam 4. If you need it. On Thursday. Next Thursday. We'll cover only chapter 8.
Chapter 8. So nothing that we're going over right now.
Right, not from the 9th of February. So I'll just keep it to chapter 8. So, gases. So we'll just focus on gases.
God bless you.
Thank you. Thank you.
And then sometime towards the beginning of next week, Monday or Tuesday, the final will be up on my PCC that in you. The final will include chapter 9.
Oh, okay.
But no, we're not doing 11 now since we didn't have time.
We won't.
Do you have the discrete?
No, that's only 2.
Okay.
There's only,
Crash
I
course.
don't know if that's gonna be like on the Hesse and stuff, so.
Or on
I mean, I can
Tuesday.
go and do it myself, but.
No, on Tuesday I'll look at least the main points.
Yeah.
We try to touch on
What?
respiratory alkalosis,
I don't know
acidosis,
if it's there, I can't see it.
metabolic.
You haven't, you're signing the Hesse?
Oh, sorry, and I forgot. So,
Oh,
in terms of the gas law, if something is changing, so if a problem has two pressures, two volumes, two temperatures, two amounts, then that means it's one of the gas laws. Okay, so if something is changing, it's one of the gas laws. If nothing is changing, if you're just missing something, then it's PV equals NRT.
oh, that's good to know.
Okay, so you kind of know that. Well,
It's the ideal gas law if you're missing something. You said, right?
So they'll give you a list of conditions, but you're missing something. But if they give you two of one, so if they give you two pressures, two volumes, two temperatures, then it's one of the gas laws. P1 over P1 V1 equals P2 V2, P1 over T1 equals V2 T2. If you guys gave any information in naming, you can ignore that. So if you get a pressure and temperature, you're not given a volume, you can assume that the volume is constant. If you're given volume and pressure, you can assume that the temperature is constant, even if it doesn't say so. If it does specifically say that something is constant, that means you can ignore it. That's that part. And remember, temperature has to mean.
Oh, yeah.
Okay. If you have a problem that asks you to solve for the temperature, it may tell you that they want the answer in Celsius. So you still do the calculation in Kelvin and then convert it here back to Celsius. Okay, so chapter 9 is on solutions. And basically, in chemical equations, the components sometimes have the state, and they're solid, liquid, gas. And then AQ means aqueous. And that means that component is solid in water.
Oh, yeah, aqueous.
A solution is defined as a homogeneous mixture of two or more substances. One of those substances is called a solvent, and only one, we can only have one solvent. The solvent is what is doing the dissolving. And the other substance or substances are the solute. So you dissolve the solute in the solvent. So you have sugar, water, sugar is the solute, water is the solvent. So the solute dissolves in the solvent dissolves the solvent. Together, we have a solution. If the solvent and solute are in the same state, if they're both gases, both liquids, both solids, then the component that is present in the largest amount, that's always your solid. All gas mixtures are solutions because they always mix evenly. So for example, in air, since 78% of air is nitrogen, then nitrogen will be your solid. Oxygen will be the solid.
Since the solvent dissolves the solute.
It solves the solid. So the semantics can get tricky.
You said all gases are solutes? Or what did you?
Gas mixtures are solutions. solutions.
Oh,
All gas mixers are solutions. Because all gas mixers are homogeneous.
oh, that's right.
Okay. So notice how one word can make a big difference. And that's a two-letter word. Yes. So the solvent dissolves the solute. The solute dissolves it in the
So that just means the same thing, right?
Yes, yes, yes. Now, if the solvent and solute are in different states, then the final state of the solution usually tells you what the solvent is. There are some solutes that are so soluble that you can end up with more of that than you have solvent. So for example, sugar is very, very soluble in water, especially as you raise the temperature of water. So at about 60 degrees Celsius, which is a pretty warm water, you can dissolve about 200 grams of sugar in 100 grams of water, and it will dissolve. And it is very, very soluble. It still doesn't switch the solid-solute component because they're in different states. One's a solid, the other one's a liquid. The final mixture is a liquid, which points to the water being a solid. When it becomes an issue, is when they're in the same state, and that's because certain properties switch. So when you have alcohol in water, one of the things that happens is that when you add a solute to a solvent, the more solid, the higher the boiling point. Of the solution.
Is that true with the freezing point too?
Yes.
But it lowers,
But it lowers.
yeah.
Mhm. And so take alcohol and water. So if you have water and you start adding alcohol to it, then the boiling point of the solution starts increasing, not much, but it starts increasing a little bit above 100. But as you keep adding alcohol, then the properties of alcohol take over. And then all of a sudden the boiling point drops, because now the alcohol is the solvent and the water is the solid.
Mm.
And instead of the boiling point being above 100, all of a sudden it drops into like the 80s. So when you have things like when I was in college, they had this thing called diesel, which is like 180 proof alcohol. So you would buy a bottle of that, put it in those big jugs of water, and then you go to Sam's and buy punch concentrate, and then and fill it up with water, and then they got a party for like $30.
So the reason why is because they're both liquids, or it's because, okay.
So that's when we have to pay attention to which one's present in the largest amount, because the properties can reverse.
Properties reverse.
So is it present in the larger amount just because it didn't dissolve as much?
Well, no, anything that doesn't dissolve is not part of the solution.
So solid, liquid.
But you were saying that like you do without using like water and alcohol. So if you add like alcohol to water, it's gonna raise the boiling point. But if you keep adding alcohol to water, the water's gonna take over the alcohol's property, so the boiling point's gonna go down. So then they switch places where water is the solute and alcohol is the solvent.
In your radiator. So you cannot purchase pre-mixed antifreeze, or you just add it directly in your filter. But if you buy the concentrate, you have to pay attention to the ratio of water and antifreeze that you're adding. Because the solution in your radiator is supposed to be based on water, not on methylene glycol, which is the other component of antifreeze.
So antifreeze is just used in the winter.
No. And as she was mentioning right now, she asked. What I put that increases the boiling point. It also lowers the freezing point. So antifreeze is sold on this property, but it's also doing this. It's also helping that solution remove more heat from the reaction without building up too much pressure. That's it. Right, so solutes may be liquid, gas, solid. Think of a pop soda, a carbonated drink. Water is the solvent, but you have sugar, which is a solid solute. You have the CO2, which is the gas, the solvent, and you have the syrup, which gives it the flavor and the color, which is the liquid. So you have a liquid, gas, and solid, the salt, and then a liquid. So solids can be either state. Okay, they have to spread out evenly throughout the solution. If it's not spread out evenly so that it's homogeneous, then it's not a solution. They cannot be separated by filtration, so if you run it through a filter, then everything that passes through is part of the solution. So when you're brewing coffee, what comes out on the other side, filter, that is
The solution.
the solution. There's other ways that you can separate them, though. Evaporation, and so in the case of when the solvent is liquid, if you evaporate the solvent, and your solute is a solid, you can get the solid back by evaporating solvent water. Once it's dissolved, then the solute should not be visible. You shouldn't see sugar crystals or salt crystals in the solute in water. But a solution can have a color, and then going back to coffee. When you brew coffee, what ends up in the cup is it's a solution, and it has another color too. Now, one thing we're going to see in a little bit, we're going to talk about electrolytes, is that for ionic compounds, when they are dissolved, they will break up into ions. Okay, that AQ means that that is dissolved in water. AQ means dissolved in water. So this is a copper sulfate crystal. And as it's dissolved in water, it's breaking up into copper ions and sulfate ions. Spread out in the water. But they're spread out in this side. So examples, as I mentioned earlier, air is a gas solution. Nitrogen being solvent because it's present in the largest amount. And that's some examples of gas in a liquid, your pop soda, salt in water. And then metal alloys are considered to be solid solutions, so brass is a copper solution of copper with zinc, something a little bit of chromium in there. Steel or your hardened steels will contain small amounts of carbon. Your stainless steels, in addition to carbon, they will contain chromium, zinc, a couple other atoms I think but all those are considered to be solutions. For the most part though, we're concentrating on water-based. Because of water's high polarity. Okay, water is known as a universal solid.
Universal solid? Solid or solvent? Oh, sorry.
Well, it cannot dissolve everything. It is a substance that can dissolve the largest types of compounds. So it can dissolve
Can't dissolve everything but what?
The largest, like in big and small large, or just the largest?
in
like-
terms of categories,
Okay. Like the most?
the most different types of compounds. So water is polar, it can dissolve anything that's polar, period. Like dissolves light. It can also dissolve a large number of ionic salts, ionic compounds. So your metal, non-metal combinations can dissolve a very large number of those. And sometimes with the addition of another component, sometimes called surfactants, it can dissolve nonpolar compounds.
That's true.
So we teach you that oil and water don't mix, but they can mix. And I think I mentioned this at the beginning of the semester when you have something like milk. Milk contains fats, which are oil type substances, and they're daily solution in water. They're mixed in so in this mixture. So it doesn't do it automatically. It does have to go through a process, and that's why milk says homogenized, because it has to be forced in the process of doing it, but hell, water can do that. Unfortunately, because of those properties that water can dissolve almost anything, is that we used to throw everything into the oceans. So old trash is just thrown into the oceans. Here it is so large, it can dissolve anything. It'll just take care of it. And
That's
now-
what they thought?
So back in like New York, all trash would be put into like Manhattan. They would put all their trash into these boats, and then they go into a mile or so. I don't just see them, then just dump it in the ocean.
Really? I didn't know.
And so it was, and it's a lot better now, but it was heavily contaminated, the water surrounding Manhattan and Long Island,
Because they have an island, right, where you take all the trash?
Staten. Or at least they used to, and then Staten Island became the trash bin of the New York boroughs. But yeah, they used to dump, and you know, along the Mississippi River and all that. So, you know, 30s, 40s, 50s, a lot of factories would set up close to river water areas. And the sewage discharge, chemical discharge would just go directly into the river. And this goes back to before Venice would have. In Europe, and when you had homes next to rivers, basically people would open their front door, walk up to the edge, and then just throw the trash into the river. Just yeah, there was the trash. There wasn't any trash collection services or anything like that. So pure water will take care of all that, but it doesn't.
They thought it would disappear or what?
Yeah.
Yeah.
Really?
Pretty much. In terms of the light dissolves light. And, should I forget, sorry. Okay, I believe the top layer is water and the bottom layer is a non-polar solvent, like in wood. In here, iodine is added. And so iodine is non-polar. So it did not dissolve in the water layer, it dissolves in the oil layer. Okay. And then over here, this is, I think, a chromium salt.
A what?
A chromium salt. I can't remember exactly which one. In the book, it tells you what it is. That salt does not dissolve in the oil substance, but it did dissolve in the water substance.
Because it's polar?
Because it's ionic.
Oh, ionic.
And the water can dissolve some ionic salts.
The first one was water and what?
So these are the two salts, water and
And what?
oil.
Oil, I'm sorry.
I can remember which one.
And it's polar.
I'm gonna say hexane. Polar on top, non-polar on the bottom. So they're not mixed. That's what you can
Yeah.
message. And then you add iodine crystals. And if you mix it, then the iodine will dissolve here, and then eventually it separates back, so the water stays on top. The hexane and iodine, dissolved iodine water. Here, then the chromium salt dissolves in the water, but it didn't mix.
So it does mix? Water and
Non-polar doesn't, but polar and
But
ionic.
not with them. So if we I'm gonna say it's hexane. So water's polar. And hexane is not polar. So they're not mixing. And you can shake it and it'll mix, but not homogeneously. Just like holding water, and then as you let it settle, eventually it separates. And then you add I2 in here. And as the I2 mixes in, and it dissolves down here. But it did not mix with water. And I'm just gonna say this is chromium. Can't remember what it is. So we have chloride, it doesn't mix with the hexane, but it does mix with the water. So if I2 had mixed with the water, then the top layer would be purple.
It is a little discolored.
Dirty.
But it's still not mixing, right? You're saying, okay.
And then the other side, likewise, the bottom layer would have been green. So, like the salts, like polar mixes with polar, non-polar mixes with non. For salts, for ionic compounds that are soluble in water, then they will split up into their ions. Whatever ions make up that salt, they separate when dissolved in water. So you have charged particles floating in water. So when the salt dissolves in water, it breaks up into sodium ions and chloride ions. And you end up with an electrolyte. An electrolyte is a solution that can conduct electricity.
Hmm.
An electric current happens when electrons move. So when electrons move in one direction, an electric current moves in the opposite direction. And basically, because you have positive ions floating throughout, electrons can jump from positive ion to positive ion to make it from one end to the other. Without those positive ions, the electrons wouldn't make it through. Okay. Pure water is non-conductive. and we'll do that test tomorrow. We'll put the electrical wires in there, and we can put a finger in there, and we'll fill in.
How do people get shocked when they're standing in water, cause it runs
Because it's
through
not
it?
pure.
It's
Because
not pure water.
That's the key.
What does it have in it? Like, why is it?
Mineral salts.
Oh.
The hardness, whatever makes water hard, the harder a water system is, the more minerals it has, minerals or salts. Will contain.
Like here, it's so hard, your hair
Yeah,
kicks up.
there's a lot of minerals in it, added.
There's all kinds of stuff in the water. I went to Ohio after being here, and I was like, my hair is so soft. I was like, what's wrong with you? I was like,
And not that it's,
Is that what the hard water stuff in your time?
like I have a filter on my, just on my shower head that like filters out the hard minerals out of the water. But it's not as hard.
it, well, when we get to solubilities,
So it has electrolyte.
right, the water softener does not lessen the amount of electrolytes in the water, but it lessens the number of non-soluble minerals. And it does make a difference. And so, the harder the water, the more conductive it is, but that doesn't mean that if you live in a saltwater place, you won't get a chance to get electrocuted. There's no chance that you'll get electrocuted. But if you were to fill your tub with distilled water, you can plug in the toaster, dump it in,
Oh, no.
and nothing will
But
happen.
that's why you can't drink distilled water all the time, right? Because then you
It will
can
dilute.
dilute your electrolytes in your body.
Huh?
You can't drink distilled water all the time because you'll dilute the electrolytes in your body.
No, I heard you, but I didn't. I was so confused. I
Distilled
was like,
water is
huh?
like pure water, so it
That's
doesn't have any
crazy.
kind of like
It's about
electrolytes
all
in
the
it.
chemicals.
Anything that you consume, as it runs through your digestive system, the body takes out what it needs. As you're drinking, if you're properly hydrated and you're drinking distilled water, then the body doesn't need anything. And it just runs straight through. As it's running through, it's actually picking up stuff. It's removing stuff that it needs.
That's crazy.
So, polar compounds will dissolve in polar solids, but they don't break up into ions. You just end up with a mixture of the two. So polar dissolves polar, but it does not break up into ions.
Polar dissolves polar.
But you do not end up with an electrolyte. You end up with a non-electrolyte.
If you dissolve polar, they're called, when polar dissolves.
Will those like specific questions be on the test like that? Or am I like worrying too much?
On the final,
Yeah, okay. Well, no, not on the final. On the next, you said the next test is going to be over this, 9.
no, gases.
Oh, yeah.
Yeah.
Sorry. Okay. Yeah, I'm wrong. Never mind. Oh, so it won't matter. We can just like look everything up. Okay. Carry on.
And then as we saw here, I2, which is not polar, will mix in your non-polar compound. So I2 will dissolve in your oils or greases. And so that's what. So in terms of solute and solvent, we're just gonna go by the amount. And the density of water is 1 gram per ml. So however many mLs you have, that's how many grams you have. So if we have 100 mLs of water, that means 100 grams of water. Okay, so for A, you have 2 grams of sugar, 100 grams of water. And we're looking for the solid. So we're choosing the smallest. So sugar is less, that's your solid. For B, ethyl alcohol 60 and methyl alcohol 30, so 30 is less than 60. For methyl alcohol is your solute. 55 mLs of water, that's 50 grams versus 1.5 grams, so we're going to see your solute 800 versus 200, so 200 of oxygen, oxygen is your salt. So we're just basing it on the smallest amount, the sodium is the smallest. So no sugar, or methyl alcohol, drugs. And then for the ionic salts. So whatever ionic compound you have, remember it's cation, anion, positive, negative, and your metals are positive ion. Your non-metal or polyatomic ion is a negative one. But if it's soluble in water, we'll bring it up. And the positive ions end up being surrounded by the negative polarity of the oxygens. So in water molecules, the oxygen has the negative dipole, the hydrogen the positive. And so positives attracted to the negative, and then vice versa. The hydrogens. Orient themselves as the negative ions. So lithium, which is positive, will be attracted to the oxygen, and the negative Cl will be attracted to the hydrogen. So we make a prediction on whether it dissolves in water or not. We'll go with the assumption that if it's a salt, ionic compounds are salts, and it's soluble. So anything that begins with a metal will be soluble, so A is soluble. Water's polar, anything that's not polar, non-soluble. And then earlier on the board, I told you that I2 is non-polar. Remember, anytime you have only two atoms, actually not two atoms, two elements, if they're the same, non-polar. If they're different, they're polar. So two of the same non-polar, two different polar. So soluble, soluble, non-soluble.
Fast.
And A little bit later in the chapter, we'll go over solubility rules so that you can make a prediction on whether an ionic compound is soluble. And from those rules, we're gonna go to the extremes either. Yes, it's soluble, which means it completely dissolves, or no, it's insoluble, which means nothing dissolves. There's a middle ground, but to make things simpler, we'll just put things in the extremes. So if we classify it as soluble, then we assume that it dissociates completely. That will make it a strong electrolyte. So anything that's soluble, any salt that is soluble will be a strong electrolyte. Strong acids are strong electrolytes, and there's 7 strong acids. And those are distributed.
Hydrogen, chlorine,
And oxygen.
and oxygen.
HCl and oxygen, or oxygens to be oxygens. From a chemical formula, anything that begins with a hydrogen is an acid. So,
Oh, I wrote this one wrong. Anything? Starts. Sake.
and quotations means the same. So I don't think they teach proofreading symbols anymore. High school.
Oh, not high school. I don't think my first process is.
You're in high school.
I also, I think I learned in high school too, but I think in high school for everything else.
Okay. So, your strong systems. You're gonna have an arrow that goes in only one direction. And the assumption is that they dissociate 100%. So if we put 100 molecules of NaCl, then all 100 break up, giving us 100 sodium ions and 100 Cl ions. Okay, so 100% dissociation, we assume that everything breaks up. And that's what a strong electrolyte is. In a weak electrolyte, then we're gonna have double bonds. Because that means that it's actually going in circles. It's dissolving and then it's recombining. It's salts and break up. Okay? And only a small percentage actually breaks up. It's a weak system. So like 10% breaks up. And we end up with 10 ions, but most of this here, no. It continues to dissolve, but then this recombines. And it just goes in circles. And that's what a weak electrolyte does. From the images, and here everything's ionic. Everything's positive or negative. On the weak system, these are together, these didn't break up. Okay, so we have 1, 2, 3, 4 that are together and only one that breaks up. 1 out of 5, like 20%. Okay, but most of them stay together, a few break up. And then that breaks up, that recombines, that breaks up, together recombines. It's going in circles. Okay, so if it's ionic and soluble, it's a strong electrolyte. It's one of these 7 acids, it's a strong electrolyte. If it begins with hydrogen and it's not on this list, that's a weak acid. If you're given the name and the name is not on this list, that's a weak acid. Okay? Weak bases are weak electrolytes. The only weak base that you need to know is ammonia. That's the one weak base that you need to know.
Ammonia.
So real quick, this is a weak acid, HF. So it begins with hydrogen, you know it's an acid. You look for HF here, it's not here, then it's weak. Now, the other thing is, if you're given the equation, if you see the double arrow, that's a weak system automatically. Now, if it's a non-electrolyte, it dissolves, but it does not conduct electricity. So alcohols, sugar, and water, those are non-electrolytes. They still dissolve, but they do not conduct an electric current. So you'll see some of the strong acids that are in this list: HCl, HBr, HIHNO3, HCl4. HF is not in this list, it's a weak acid. Acetic acid begins with hydrogen, it's not in this list. The one weak base that you need to know is ammonia. Okay, that's a weak system. If it's a polar, then non-electrolyte. Okay. Water is considered to be a very, very, very weak acid. But it's so weak that we don't even consider it to be a weak electrolyte. So water will not conduct electricity. So your salts, they dissolve, they break up into their ions. Okay, the name helps you find out what the salts are. Okay, so CaCl2, that's calcium chloride. So it's made up of calcium ions. What's the charge on calcium?
-1. Oh, calcium, positive.
What's the charge? Chloride. And it's Cl negative. So those are your 2 ions. What's potassium?
Oh, just like
Potassium
that. Okay.
It's K plus.
But polyatomic ions aren't gonna like.
Go
stay-
nicely.
They'll stay at
Right.
this set, right?
And that's why the name potassium phosphate, it's a phosphate ion. So you look for Ca and Cl. Ca2 plus, Cl minus.
So you just look up the charge on the periodic table and that's it. Okay,
But do
so
not break this up into Ca and Cl2.
no, because the charge is the subscript.
So that 2 is this 2,
Oh, okay.
because of the balance equation.
Okay.
So K3PO4 breaks up into potassium ions, K plus ions.
Okay.
Not break up into K3 plus, except into to K plus, now that 3 needs to become 3 of those. And then the phosphate stays a phosphate. It doesn't break up into phosphorus and oxygen, like you mentioned. So the nomenclature will help you figure out what those ions are. Okay, so which of the following reactions represents a dissociation of a strong electrolyte in water? So we're looking for a strong acid or a salt. You know it's an acid if it begins with hydrogen. So nothing begins with hydrogen. So we don't have any strong acids in there.
The C starts with the salt. Like, yeah.
And so a salt begins with a metal.
Solid or solute?
Salt.
Salt. Oh.
That's it. And then salt. Salt means that's an ionic compound. Salt means. So all your ionic compounds, all your salts begin with a metal. Of the four, which one begins with a metal?
Yeah.
Carbon.
And that's it.
Oh.
That's it. So we have C. So if it's breaking up, it breaks up into ions. Once it's dissolved, then it becomes aqueous. So on the right-hand side, because polar solutions are water-based, right-hand side will always be aqueous. Whether it's a strong, weak, non-electric, doesn't matter. It's always aqueous. So K2CrO4, that's potassium chromate. So potassium chromate breaks up into potassium ions and chromium ions. And now we do have two balance. So there's one CrO4 that doesn't have parentheses. And we have two potassium salts. So I need to put a 2 here. Your acids will always break up into hydrogen plus. That's what makes them acids, that they have a hydrogen ion. And then whatever the hydrogen's combining with, that's your negative ion. So PO4, and that's positive. Now to balance it though, we do have 3 hydrogens. So we need to put a 3 here. If it's weak, the arrow needs to be pointing in both directions.
Oh.
So either that or. And then for your non-polar, because they don't break out, the only thing that changes is the same. So all that changes is you change this into EQ.
Okay.
Okay, so that changes to EQ, that changes to EQ.
When it's polar?
When it, So we don't, all it does is just copy it again, and say.
Okay.
And keep in mind that this is, at this point, more for you to recognize the weak, actually the weak from strong system and an non-electrolyte. So if it's not splitting up, it's a non-electrolyte. If it's splitting up, it's an electrolyte. Single arrow strong, double arrow weak. So we're here for today. And then tomorrow,
We'll finish up.